So welcome to the developers meeting on Sunday, 19th of February 23. First things I want to talk with you is the adapters that we are having 3D printed in Europe and having sent out to a couple people here in Europe because we want to test the adapter. I'm talking towards to the people who have received a camera and an optic. So what you
Okay.
now need is a 3D printed adapter. We developed that adapter since December. We are now in version 2.4, and now we have a discrepancy. So Oliver, who prints them on several printers to make sure that we have a sweet spot on an average of printers, um, that that the last version 2.4 is optimal for his camera and his yeah, putting it together. Then he printed the adapter and sent it over to me, and I could not get a sharp image. There's a focuser ring where you can adjust
No.
the latest 0.2 millimeters of variation
Wow.
in the
Okay.
axis. So it's in the fisheye. And the idea is to have that indicator of that focuser ring somewhere in the center, so that you have space to the left and right, enough space to have to get a sharp image, not to be on an end where you can't move any further. So
Okay.
that what happens when the version 2.4 was printed by Oliver and sent over to me, and you both you get it, Lionel and Yannick, you already have it.
Mm-hmm.
And there's Mike. Hey, Mike, can you hear me?
I received, yeah.
Hey, Mike.
Hi.
Hey, by the way,
Hi
Mike,
guys.
did you receive a package from us with 3D prints?
Not that I'm aware of, no.
Oh,
It
okay.
usually takes a little while to get, yeah.
Okay. So you didn't even receive the enclosure yet?
The enclosure,
No.
no.
Okay. Okay. Yeah.
Okay.
You would have known when you heard that now. Okay. So you didn't receive it.
Yeah, no.
Okay. Got it.
No, I've not. Oh,
So I'm talking
sorry.
about only you will receive 3D printed stuff like the adapter for the camera. So to fit the optic on it and to fit the sensor on it. So to create the whole camera. Yannick is the only one who received the adapter by now, and me. And my experience with this adapter is that I do not get a sharp image even if I turn the indicator to the far right.
Mm-hmm.
And today, Christian, also who received the same adapter. Lionel, sorry, can you turn down your mic, please?
Sure.
Thank you. So Christian also received this adapter, and he was adjusting his camera. Um, there is one point where you can recognize whether your setup on the camera is correct. So when the camera, the sensor, the big thing, meets the adapter, it should be a close touching face there, so that the camera is really touching the adapter. If you got a little gap in between, so you then even can put your fingernail in between, then this gap is too big. And that's the case. That's the case for my adapter that I got from the same print range that Oliver left from one printer. What I want to say is there can be variations in the print, or my camera is different. So that's what I want to say, Yannick, is
Mm-hmm.
when you attach the camera, the sensor, and the optic on the adapter, make sure that when you enter the optic on the adapter, that there's a slanted rim on the optic on the outside. So this slanted rim shall end exactly, so the slanted rim and the vertical where it ends shall
Mm-hmm.
exactly be flat with the adapter. So when you put in the camera into on the adapter, there's this slant, and the slant, there's a little nose that goes into this little slit, a groove, but the slant of the outer rim of the optic shall be flush with the horizontal surface of the adapter. So that's the one
Okay.
indication, and the second indication is that the camera, the sensor, when you put it underneath the adapter, it should be total flush with the adapter. There should be no gap. Then you are on the right side. So make sure that happens
Yeah,
first.
I have to revisit that because I still waiting for the accessories, like
Screws.
these four-sided nuts.
Yeah.
Is that the right word? Yeah. I went to my local hardware store yesterday, and they have the M5 and M6 nuts, but of course not the M4. So I had to order them online.
There
I'm
is
still waiting for that.
Schraubenking.de in Germany.
Ah, okay. Yeah,
Schraubenking.de,
okay.
and they are
I
very
can
quick.
try.
Yeah.
Okay, I can try that. But I also already found them on Amazon. I don't
Okay.
want to make a commercial for that, but
Okay,
yeah.
but you wouldn't need the screws at that point, just to know whether the adapter is right for your camera, or you have an issue. You might
Okay.
have an issue, like me, like I had. Um, as I said, when you put the optic on the adapter, then the slant of the optic shall be so that the end of the slant is flush with the top level of the adapter. And on the other side, underneath, when you attach the camera, there should be no gap between the adapter and the camera. So, and you
Okay,
don't need any
understood.
screws to check for that one.
Okay. And I also still have to get the accessories for the cam itself, so I still need to buy a USB cable, I guess.
A USB cable
Um,
shall be along with the camera.
um,
There should be
really?
yes,
Okay, I have
a
to
black
check.
one, a black USB cable,
Okay.
1 meter length, and important aspect is for this special plug. You see this
Yeah,
one?
yeah, right. Yeah, I have to check. I
With this
probably
nose,
have that.
okay?
Okay. And also the power cable. I still need one. And I think Oliver shared a link where we can buy a power cable that's
So either it's
it's
a
the right
12.
one.
So first of all, the camera and is powered by the USB, okay? In
Oh,
the
okay.
back of the camera, you have a power plug. No, where you can plug in a power cable. Either you already have such a cable, or you buy the adapter, the plug, and take a cable, and either you have a power supply or you use your ATX power supply unit. So whatever
Okay.
you prefer.
Yeah. I just
Um,
found
the
the accessories for the cam. Yeah.
Where did you find? Are you in the box? You found
In
them.
in the box, yeah.
Ah, okay.
Yeah. Yeah. All right.
Okay. So one thing is important to know about the camera. The camera itself is powered by USB, and the power supply at the back in the center is only for the cooling. So you can run your camera even without the cooling, just for testing. I
Mm.
mean, you do not have always to plug that one in just for when you're doing your software testing and so forth.
Okay.
Okay.
I see.
Yo, that was that point. Yeah, Wayne said that he has to leave early, so let's start with Wayne and let's talk about the some installation issues you had. I saw on the dev support on Discord there were some issues. Maybe Wayne, you can give us a status update what your current situation is.
Well, we did get it up and running. My problem apparently was that I had two versions of um, what was it? I'd have to go back and look at the talk. I had two versions of hmm, oh open
OpenCV?
OpenC. Yeah, I had version 3 and 0.3 and 0.4 both, or 0.4 and 0.5 or something.
Mhm.
And after he figured that out, my system is up. It works now. Also, I should have my big printer up and running this week. I don't know when I moved, maybe from having it off for a while, so I should have, and I plan to print those. I don't have a camera or a lens to stick in them, but I do plan on printing everything. I got a goofy idea maybe, but the 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 container you make, whatever you call your big box, um, it's almost the same exact size as a 27-gallon tote that I can buy at like Costco. And so I plan on just printing printing some adapters and actually using a tote. Um, that way you don't have to have a container, a box shipped all the way from Europe. And they may change, right? So I just figure I would modify a 27-gallon. I mean, it's within millimeters of being the same exact size. I don't know if you designed it that way or if it was just a coincidence,
Coincident.
but it really, wow. I mean, in every direction, it's
Really?
within a few. Yeah, yeah. There's Fabio's. He might remember exactly. I mean, I know my open C was wrong, right, Fabio?
Yeah, yeah, your OpenCV. Yeah, I don't know why. We just have
That was the
to
main
raise it.
issue we had, right?
Yeah, yeah.
And so other than that, I'm on a Windows 11. I tried to run it through a virtual terminal. We couldn't get that to work, but maybe that was the same issue, and we just never. Me and Mike was never able to figure that out. Um, but when I switched off from a virtual terminal to just using WLS or whatever, then Fabios was able to
It works. Yes.
It works now.
get
Okay,
it working.
perfect. Yeah, okay, great.
So that works. Yeah.
Okay, is this
That's about
something
all I
that
really
we
have.
now learned that we only need 2.4 or which version was the correct one?
No, I it was something weird because one of his Docker images has the OpenCV 3.7. I don't know why. The 4.7. The 4.7. And it makes no sense. And the version the 4.7 that was installed there didn't have some of the features that we use. So I had to just erase that container and create a new one from scratch, and then install with the 4.6, and it all worked.
Okay, so you create a container that's just ready to download. Perfect.
Yeah. We just re-downloaded the container that you have on Sky 360, and it worked.
Perfect.
Yeah.
Okay.
And the container definition, it's all in the simple tracker ROS WS repo. It's not like something that's defined elsewhere. It's 100% in that GitHub. Newest team member.
Yeah. Everything was fine. It's just his installed version. I don't know why. It might be some with this. We were playing with a lot of different things that we might have installed for the 4.7 for wrongly there.
Okay.
But when I just erased the image from the container and got it again from the Sky 360, it worked. So it was just something weird.
I tried a lot of stuff to get it to work before I got a hold of Fabio.
Yeah, that might be it. Yeah.
And I might have did it. I watch too many YouTube videos, and they'll say to do one thing, and I'll try it. And the next YouTube video will say, "Oh no, don't do that! That'll mess everything up." And yeah, they were right. It did. It messed. So I mean, I don't know how many times I redid a virtual terminal. Huh, Mike? It was a lot. And
so okay, Wayne, what do you want to say is that you are now able to go along whenever new push requests are on, new branches exist, you can update. Perfect.
Yeah.
I'm working on getting you a camera and an optic
Okay.
on a landing agreement with us. And
yeah, don't bother to send me a case or any of the 3D printed parts. I have a huge 3D printer.
Yeah,
I just plan.
I get that.
And I just plan on converting a tote. To be honest, I'll set it upside down, cut the ridge off the lid even, and stick it up in there so it doesn't let water seep in.
Yeah,
I think it's be a good alternative
do
until.
us some photos. Let's have a look on that.
Okay, yeah. When
Yeah,
I get it
maybe
done, I'll
it's
send
a
you some
cheap
photos.
solution. Absolutely.
Yeah, it'll save $300.
Yeah, true.
If somebody wants to build one. But I mean, it's unbelievable how close. I don't know if you guys have totes like that. They're usually black on the bottom with a yellow lid. You buy them at I buy mine at Costco, but Home Depot, they sell them. And because you sent me the 3D. Remember I asked you for a 3D thing of your case, and I mean it's within millimeters, like 5 millimeters in every direction, except maybe the height is a little, maybe 10 or 15 millimeters difference. But I mean, it's so close. And I'm going to 3D print a thing because it comes with reinforcement line, troughs in it and stuff. And I'm going to print a base like for where the camera goes that'll fit right down into them, so it'll just all match up. And anybody in the United States who wants to go cheap route can go to Costco and pick up a tote, and I'll just 3D print them the parts and send them to them.
Yeah, let's see that because there were a lot of approaches in the past with the tubes and pipes and everything. Let's see how it turns out. Okay.
I got a question while we're at it too. The telescopic camera that you're going to use, and you made that clear lid. I mean, you apparently haven't made any, but that you're going to put a clear lid over, and you have that dome spinning.
Yeah.
My thought was to just have a big plastic dome that's round everywhere so that it can spin inside it. So this thing doesn't have anywhere for moisture to get in. Why was you going to turn? I'm wondering why you're going to turn that. Was there a reason?
Yeah, temperature was the reason. So when you have an open dome, sunlight can penetrate the interior. So the idea was to get sun as far as out as possible. That was the only reason.
Cut down on heat. Okay. Yeah. Makes sense. Might be able to take care of that with ventilation. I'm just thinking that I could keep it watertight easier.
Yeah, there was big concern by Christian about he calls it it's called seeing, which means it's these air vibrating in air fluctuations, heat fluctuations in the air. Okay, when your camera is sensitive enough, it can pick up that, and you get a noisy image. And to reduce that, we were talking about controlling the interior climate of the box.
Filling it, maybe.
Certainly the direction to temperature, but also towards humidity.
Oh yeah, humidity for sure. Humidity should be pretty easy to do.
We tried with everything we designed on the box, as you see it on the website, for example, that to keep all the weather situations in mind. So sun especially.
Yeah. Okay.
So as few as possible penetrations of sun to the interior. That's why it's also the adapter for the All-Sky Cam is so not small.
Yeah. Right. Yep. Okay. I'll keep that in mind as I'm building.
All right.
Thanks.
Perfect. Okay. You said we were talking about thermoforming, and I sent you the model of the PTF hood, and we were talking about how to produce that from acrylic and to spray the interior, so to leave out the optical parts space.
Yeah, I would blow mold it. Probably would be the easiest way. I mean, that's what I'm gonna first thing I'm gonna try is I'm gonna blow mold it. I'll probably blow mold the whole one first. It could still be painted on the inside, to if you want to still spin it. But yeah, blow molding. The advantage I see with a blow mold is like you were talking about. If you had it vacuum formed, you'd have to have like a copper coated tool or something. You said it's not how we do it in the United States, but we're never that I've experienced. But I mean, I've vacuum formed acrylic many times. But if I blow mold it, it's just a process of having a round hole with a controlled airflow coming in the bottom, and as the plastic blows up, you have a light with a sensor on the other side, and as it hits it, it shuts the vacuum, hits it, shuts, and eventually it'll stabilize there, and then it'll cool there, and you end up with a nice round dome that's never touched a tool. Takes a little practice to, basically it's how fast you apply air. If you apply air too fast, you'll get thin spots. Too slow, it'll cool and
Yeah,
you'll
that's
get
true
thin
for
spots.
spherical domes, right?
Yeah, right. For like I mean, for what you wanted to print, of course, you couldn't do it that way with the hubs on the sides. That's why, your little, I don't know what you want to call them, fenders, like you had kind of on the side of yours, with just the center was a dome. I was just going to make the whole thing round. I don't see any reason not to.
Yes,
You can
why
still
not?
paint it.
Yeah, true.
Yeah.
Yeah,
And
true.
so that's what I'm going to do is I'm going to blow mold mine. I have the equipment. I've done it for years. I mean, I'm kind of retired from thermoforming now, but I still have all the equipment, machines, and
Okay.
of course you never lose the technology in your brain.
Would be
Hopefully.
great to have some prototyping there. So
Yeah,
to
when I
see
get
whether
it,
the
when I
acrylic
get
is
it,
sufficient enough for the optical system.
yeah. There's other options besides acrylic too. I mean, we used to actually form windshields for cars, and that was what they called drape forming. That was kind of neat. We used to make them for Corvettes, and you just had this huge tool, and you heated up a sheet of plastic and just set it on it, and it just draped to it, and it was the windshield for a Corvette. That was kind of cool. But so there's other plastics that can be used besides acrylic but even plexiglass. So.
Okay, so
But I'll mess around with it for sure.
Yeah, perfect. I think someone has to go that route, and we have to find out what the best material is and the best method. Perfect. Thank you, Wayne.
Yeah. And like with your adapter for the camera and the lens, I'll be able to play with that and maybe come up with something that I'm pretty good with blend. I'm pretty good at designing 3D parts. I might be able to come up with a way that's a little more adjustable. I don't know. I haven't been able to print one yet, but this week I should have my printer up and running. I know what's wrong with it now, so it's just a matter of the manufacturer.
We have an adjustable adapter, so one that you can screw and it moves in the axis of the camera.
Yeah, you just said yours wasn't. You just said yours wouldn't move far enough or something, and so maybe we can make something.
It is my camera. So we have a version
it's your camera?
2.4. I'm not sure where the problem sits.
Okay. All right.
I have an adapter, and Oliver has the adapter, and Christian, and now Yannick has it, and others will get it. So we get an idea where the problem sits. For the same part, 3D part, printed with the same printer, with the same setup, that there shouldn't be differences when you have the same camera and the same optic. But somehow there is, and we have to find out where the issue is.
Sometimes it's just 3D print, yeah.
It can be.
Yeah.
But then on the other hand, the first one was 3D printed as well. So actually,
well, I mean, just like different temperature in the room can make the part different size.
Different flow rates as well. And I know
flow rate, everything. Yeah, I mean,
Cereals.
The biggest thing is
the printer.
Biggest thing is the room temperature.
If the printer, room temperature. But if the printer
it's going to shrink different. Yeah, it's going to shrink different for sure.
The moisture of the filament can affect that too.
Yep. I always I use ABS, and I always put it in a vacuum box, and I draw a complete vacuum on it, keep it warm for 3 or 4 days, make sure there's no moisture in it. Okay. And then my 3D printer is enclosed, so it stays warm inside. It doesn't get breezes from the room.
So the thing is, when it's good to consider all this, but we need this to be multipliable. So if someone in Australia wants to print it, he shall take a 3D printer from the shelf and be able to reproduce it. That's the key.
Yeah.
That's where we want to go. If we can.
I understand that if it's possible. Yeah, if it's possible. It just depends. It depends on how tight of tolerances you have. If your tolerances are loose, you can do that. But if they're really tight, it might be hard to do.
The tolerance is between 0.1 and 0.2 millimeters. Somewhere there's the sweet spot. And that's within the range of normal 3D printers. Actually, it should work. There's the focuser ring, and the focuser ring has there's a how you say
a good 3D printer shouldn't have any trouble.
Pardon
a good 3D printer shouldn't have any trouble. But there's a lot of bad 3D printers out there. That's the problem.
Yeah, okay. We're not taking into account all these
A
bad
good Ender
ones.
3
We
or
can, yeah,
something like that.
of course,
Yeah.
yeah. Assuming that the
Oh.
printer is
Lux.
okay.
Yeah.
If you need a test on a bad 3D printer, send it my way.
I got some of the. I own 9 3D printers, and about 3 of them are good ones, and the others are
So
questionable.
there's a, because the focuser ring has some degree to move. I think 90 degrees you can move it, and by this it moves the optic inside closer to the camera. I think by
Right.
0.1 between 0.2 millimeters, round about that. And that's exactly where our accuracy is. So when we have this ring, let's say the sweet spot is in the center at 50%, we have to the left and the right enough room to move. But if it's in my case on the very right, then it's not the right one. So anyhow,
Okay.
there's one thing I wanted to mention. We added a page to the website. It's not published. It is published, but it's not added to the menu yet because we will enhance it a little bit more. And it's about all the same question that we face so often. It is, how big is a certain object in a certain distance with a certain size on the material of a particular camera? And that calculation involves some parameters and so forth. And now we have the page. When you go on sky360.org/tools, then yeah, you can see what kind of parameters you can change. And at the end, when you scroll down, you see the result, which is the number of pixels that are represented by that optical setup from that particular object, from that particular size and distance. Okay. I just wanted to put it out so that you can have a look in it and get yourself familiar with it, because we see so many people asking these same questions, and I think it's good that we all know about this, how it works, and what these parameters work into each other's. So hey, Paul, good to see you. Paul, you there? Okay. At least I tried. All right. Yeah. Okay. That was, let's say, things from the side. Let's go to development. Anyone who wants to present us anything, a demoing or giving us an update of the current days, or
I have something to share, but it's outside of your normal conversation. It's like an introduction, technology introduction.
okay, yeah, why not? Let's do it. Go ahead.
So, and I know this is being recorded, so I'm not going to tell the domain name because it's in beta at the moment, and I'm happy to share it with anyone here, anyone involved. But essentially, I've been working on a technology to essentially track things in 3D vector space, land, air, sea space. Obviously, a good first place to start is the air because the technology is out there. There's a lot of people who, the customer segments, aka visitors or clients to this system, are familiar with what ADS-B is, right? So essentially, we've created this platform that can not only hold this data, but also multiple forms of other streams, multiple other forms of data. It utilizes some things that you guys are exploring. I did some digging well, digging is a rough word, but somewhere you guys were posting about using 3D globes and linking maps together. And that's essentially what I've been working on, amongst other things. That's a segment of it. So for me, I think it would be good to see where the best integration points may lie and see how we could best work together. 'Cause you guys are super sharp. I love technical, nerdy conversations like this. The technology development is awesome. I want to see how, one, I could support it and provide extra value to your community as well as extra value to the community that I'm looking to build in the next few weeks with a launch, an official launch.
Okay, so let's just understand what you just said. So you're building your platform to represent 3D tracks of air land sea vehicles or objects or what have you.
Yeah.
Okay.
Yeah.
And for second is your question how you can contribute to our effort.
Yeah. So for example, I know you guys were talking about, like I said, I think it was within last week, it was posted somewhere about utilizing a 3D globe. I mentioned the other day in the ideas chat, I believe it was, you just put a positive curve on your fisheye lens and I could plop it right onto the globe. Actually have a demo of like a translucent version of that, how it would represent a fisheye and how it could flatten. But for me, it's just a collaboration. So you have 10 systems. Is there a single place where all that image data goes? Right? For me, this could be the location where something like that lives.
So first of all, we're focusing on our alpha version. We are not even published with any binary up to now. We are still developing since 1.5 years right now. And yes, we were already about to publish the first alpha, but then we turned it all into a ROS2 robotic system, and that kicked us a bit back in time. But anyways, this is at this point, I mean, we have our concept, and there's a lot of work for things in the future. For now, we focus on the alpha to have a tracker reliably working with the fisheye camera and being able to detect events and have a decision making what to happen with events. Yeah, to skip them, record them, whatever. Uh, so this is the alpha version, and actually we focus on that for now. The additional parts, and that can even be just one step after the alpha, is additional information that we want to put in, like ADS-B data. That can be either from the local sensor that you add an Arduino board, for example, with an antenna to your station, and you have your local ADS-B data, or if you do not do that, you can retrieve it from the internet via some platforms. I think Yannick can go into it if you want.
I saw an OpenSky API on GitHub. I believe you guys are working on.
Something like that, exactly. Yeah, it's just to overlay the data that is tracked, and to have correlation between things that are known and have more or less the same track routes. So to have a decision making not only on the object itself and its how it does look like, how it behaves, but also to have references from outside databases or additional sensors like an ADS-B antenna.
Sure.
So
And a lot of that, it sounds post alpha for that project. I'm working on something that could work in parallel, necessarily interruptive of current efforts. I think a demo might be it's not on live.
Were you asking where we get all the data and combine it into one location?
No,
Is that what you were asking?
That's what I've essentially been developing. I'm wondering where an integration point would be. I have a few ideas. I know I've expressed a few.
Basically, our data is open source, so everyone has access to. So when you're asking for an integration point, yes, there will be one. And for now, with the alpha version, all data that is recorded is only recorded locally. Okay, we iterate until to a point where the data is as good as we want it, and at that point we will have, hopefully, at the same time, a vault where we can store it and have it accessible from the outside. And the other part is that everything that is recorded has also metadata, which is, let's say, the tracks, the coordinates, GPS timestamps, temperatures, all kind of other sensor information, which is, let's say, not raw data. It goes into a package in a database that is blockchained and can be distributed worldwide for free for everyone to have access. So, and there will be integration points as well. So there will be, of course, in the future an API so that others can develop software and to have direct access to the data and so forth. But this whole process is we even started a standardization process in this area with other organizations. So this is all at the very beginning, and it will
I like
certainly
ground
take.
floor,
Pardon me?
and however I can help you guys, you guys are up to something.
I would say, just as a quick mention, I saw your 3D your video, your
Oh
YouTube
yeah.
video of the 3D globe, and that might be a great thing to integrate into the graphical user interface. We'll be using OpenMCT. You might have seen that, so that would be a great place to integrate that 3D map in the future.
Sure. And just, in a past life, air quotes, I was a broadcast engineer. So if you guys are architecting RTSP streams and different types of encodings and metadata, it just reminds me of closed captioning the metadata. But,
Yeah, I got it. Okay. But the idea of Rebecca is quite interesting, because first the first idea, let's say, Rebecca, was to have a 2D representation of maps, like something like Google Maps. But to have it something like Google Earth, why not? I mean, if it's applicable, if all tools that we then need, triangulation tools and so forth, are applicable to a 3D scenery, why not? I think it's great to have such a tool. By the way, what is your tool that you're working with?
you as far as tool, you're talking about the mapping specifically?
Your framework, is it Unity?
I'm using Django.
Okay.
And Python. Big
We
fan
were
of
using that before. We were using Django and Python before. We decided not to use that. We've moved on to OpenMCT, which is Node.js and JavaScript. It's much quicker than Django.
So the application right now is actually 3 different web servers proxied into one system, which actually includes a Node, includes a Django, and a couple of other things that we get too into the weeds. I find Django to be super fast as long as you program your DB queries correctly. It's just I could process the whole planet's airplanes for threat levels in 20 seconds on a really old computer. So I don't see JavaScript with
Something
its
to
whole
look into.
import float faster than that. It's just
It would be something to compare. Yeah.
And also the map is being rendered as WebGL, and also I'm using WebUSB to send RTLSDR commands to pull EDSB packets through the browser. So the installation of feeding is load website, plugin, RTLSDR, hit connect, hit enter, and it starts feeding. There's a lot of
WebGL is great.
Yeah. Oh yeah. In combination with the WebUSB, it's going to be super cool. There's a lot of different tracks, a lot of different paths that this project's going down, and I see the integration with the UI with you guys as low hanging fruit, at least, for lack of a better phrase.
You might want to take a look at OpenMCT and see how that compares to what you have going on, because OpenMCT looks pretty good to us on a lot of different levels.
I was checking
and see
that
how
out
it
last
compares.
night. I was thinking of this for like a heads-up display, like as Uber would call it, air quotes once again, God mode. Yeah, I was checking this out last night. I have no exposure to it professionally.
So, okay, that's what Rebecca means. Would you mind taking a look into?
Sure, absolutely. And where can I drop this link? Because, I mean, Rebecca, if I said your name correctly, I'm sorry if I didn't, saw the video. I don't mind dropping the URL. I just don't want it going public right now.
A link to what? Can you say what you mean?
To this website, to this project. So
Okay, I get it. Okay. Yeah, you can DM me directly, and I can put it into our private interior channel, so then we can have access. I don't do it right now because all is on record here. So.
Okay, I'll do it. Yeah, afterwards. Okay. you could share, that would be appreciated. Give you a better picture and get the creative juices flowing, I think.
Okay.
Excellent. Thank you.
Great. Thank you, guys.
Okay, so I would say have a look into MCT. Am I saying that right, Rebecca? MCT?
Yeah, MCT.
Open. Yep. Open MCT.
Open MCT. Okay, thank you.
Mhm. It's the NASA program.
Yeah.
So.
So GS. Sorry, lack of a name. Can you give us your name, your forename?
So, considering the name of this project is called Gov Surveillance, I'm going pseudonym forward. I'll tell you a little bit of my background.
Okay, go ahead.
Years ago. So, are you guys familiar with Kali Linux?
Pardon me? Who?
Kali Linux, Kali.
Yes. Yes.
Kali Linux.
I have
Kali Linux. Yeah.
There's 3 tools I published that are in there. So I come from a cyber background and I write a lot of software. So I've worked for big corporate, I've worked for government as contract, I've a lot of cool special projects. I mentioned I used to be in broadcast for a while, which is kind of boring, no offense to the industry. So for me, I like cool special things. I get to pick and choose what I work on, and this interests me. So as far as offline, I have no problem sharing. This is being recorded and streamed for archival purposes. So for the sake of project needing a spearhead, I'm not the guy, if you know what I mean. I know it's a little dance around words, but I'd rather remain anonymous on YouTube.
Yeah. Okay. No worries. No worries.
Yeah.
Okay. So for me, I call you GS, if that's okay for you.
And you, when we're off the call, you call me and we can chat. I'll open the video up.
Okay. So normally what we do is if a developer comes along and wants to work with us, of course we poke him a little bit to know what his intentions are, where he's coming from,
Sure.
what he wants to work with. So
Is
please,
that
guys,
poking? Yeah, please, come on, poke.
poke him. No poker. Look at that. Okay. So I'd say
Everyone's uninstalling Kali Linux, I think.
certainly. I'd say Rebecca is a good lead for you. So stay close to Rebecca because you both deal with the same topic. And if you decide, let's say in a week, that you still want to work with us, I'll add you as a developer with the access to all platforms.
Yeah. Well,
Okay.
I'm a path.
I would say IDO too.
Once again, Rebecca.
I would say IDO too, because he can also explain to GS how the system operates, all the different parts.
Yes.
Graphical user interface,
Yes.
ROS, and all that.
Yes.
And I think he'll need to know that too.
True.
Yeah.
Yes. To shorten his learning curve. Yeah.
Mm-hmm.
Okay, but Ido is sick at the ill. Sorry, is ill at the moment. We don't know when he's back up. So can be in a couple of days, can be in a week. Okay. So for now, stick with Rebecca, I would say. And as soon as Ido is up, again, I pick him and give him a hint that you go into contact with him and so forth, so that maybe you can make a meeting and he runs you through our concept and where we are going through.
As well, vice versa. I don't mind, showing peeks behind the curtain.
So for now, it's because we're not only this topic, so we have several topics, and that's why I say please stay with Rebecca and filter with her. It's not meant that everyone is now going into your project. You know what I'm saying?
Absolutely, I totally get it.
Okay.
Absolutely.
So I think it's someone who is familiar with this and is a specialist in. Rebecca is the right person to talk to.
Beautiful.
Okay. Thank you.
Cool.
Good to have you.
Thank you, Richard. Cheers.
You don't have to leave.
You taking me out? I was going to stay.
Okay. So, anything else you want to raise? I have nothing anymore on my list. So, guys, feel free. Mike, any update from Wales?
I think Fabio wants to give an update. So, yeah, can you hear Fabio, Richard?
Oh, damn, again. Okay, no, I can't hear him, but
Oh.
step out, step in. Fabio?
Yeah.
Oh, okay, now
Can
I
you hear me?
you. Yeah, now I can hear you.
Okay, got it. I was trying to set up something to show you guys, but the thing is that I'm being unable to connect to my Linux box here, the Orange Pi through my Windows box. So to show it there, I will have to disconnect this one here because this cord cannot connect on both at the same time like this to display something. But I don't have any audio or anything there. So I will just show you. That's just the. I was going to display you guys just the video of the KHY, the camera working directly with the background retractor and things like this. But since it's a little bit darker right now, it's not the best moment to display anything because it's I have nothing moving on my window right now. But I can just like display it for you guys to see that it's working.
Okay.
But I will be unable to hear anything from you. Okay, when I connect from there, because it's the Linux box. It's not connected to any speaker right now. So I'll figure something out later.
But you
to
can
try to show.
But you have a smartphone. You can go on Discord via your smartphone.
Yeah, but I don't think it will allow me to. Can I do both at the same time? I can try.
I think it is possible. Oliver did this once.
Yeah,
I've not been able to, but you can give it a go.
You need to go?
No, sorry, I was saying I've not been able to. You can be on Discord with two separate hardware devices, but you can't be in a meeting, I think, with two separate hardware devices.
Let me try something different then. Let me try connecting here. Okay, can you guys hear me?
Yes.
Okay, I'm on my phone right now. Let me try to share. How do I? My camera. Okay, can I replace my camera? Is it possible to display the other camera here? I never played with Discord like this before.
You want to turn the camera to the other side to?
Yeah, I would like to use the other camera. I'm trying to make the other.
There must be a symbol with a camera and two circle.
No, there's not.
Okay.
Okay. Let's see if I can. Okay, can you guys look at my screen? So this is being displayed directly.
It's gray. Your screen is gray.
Oh, is it gray? No, it's. Oh, it should be. It should be a little bit pinky because pink, not a yellowish because.
Do you guys, Mike? Do you see his screen?
Yeah, but he's just using his camera to video his screen. Yes.
Yes, okay. I do not see it because I have to get it on record. So step out and come in again.
Okay.
Now I see it. Thank you.
So I have this connected directly to the camera, to the KHY, and I can increase the brightness, in fact, exposure, and a little bit of. I can change all the parameters of the camera here, and it's connected directly to the background retractor, but I have nothing moving there. So let me try to just move the camera a little bit. Let's see if I can point anywhere there. Just a second. I'm moving the
trees are always moving.
Yeah, because I'm moving my.
Yeah, that's a good one.
Yeah, I'm trying to get to see if no, there's no plane over there, so we could look at the plane and it's moving, but we have no one moving right now. So it's just for displaying that it's we have the feed from the camera connected directly to the background sweep tractor here on the side, but since we have nothing changing on the background, we have nothing changing on the background sweep tractor, and also to the blob detection. So if we have anything moving there, we will be seeing a pink rectangle around the thing that's detected and things like this. So it's working.
Yeah. And this is running on the Pi?
It's running on the Pi. It's running right here on the Pi here.
And this is the Pi 5 or what?
That's the Pi 5. Yes, it's in the box that I got it. So
okay, so you made it running on the Pi 5. Oh, this is exceptional.
Yeah.
Perfect.
Yeah. So that's connected to the Pi 5, and the camera is here connected to the scope. So it's displaying outside there. It's just filming the background there.
Yeah.
So and it's displaying right exactly here. So. Yeah. And that's just for display. I wish we could have something moving there, so we could like at least see something on the background of the tractor and things like this. But it's not the best time of the day right now, so it's getting darker.
But you did. Is there someone walking? There's someone walking.
Yeah, it might be. Yeah, there's someone walking there.
And the background subtractor?
No, it's showing.
Yeah.
Yeah.
It works.
It works, yes. So
I like it.
Yeah, it's working. I'm going back to the
So it's running on the Pi 5 and it's running in full resolution. Can you hear Fabio? Is he saying something?
Yeah, I heard him say that he had to adjust sensitivity. Do you get that part? Had to adjust exposure.
I have to get on again. Damn. Oh no, I can hear him. Okay.
Can you hear me? Yeah. Yes, I was saying that everything's running on the Raspberry Pi 5, and I just had to put on 8 bits instead of 16 because the frame rate was very poor.
Yep.
It's just to showcase this. I'm still working on getting this thing better and the frame rates from the camera better on the Orange Pi, but that's what I'm working right now.
Perfect. Hey, great success, Fabio. Perfect.
Yeah.
And how did you, sorry, you probably explained that earlier. I didn't get that part. I wasn't there. So how did you install it? Did you, is that directly, so what's the OS of the Pi and does it run Docker?
No, it's directly on Ubuntu on Pi. Okay,
Ubuntu on Pi and no Docker.
No. Right now, no. There's no Docker there. I'm just using the Sky 360 lib that I'm building in C++. That's everything is done there on the Sky 360 lib there. I'm not using any Python code or simple tracker or anything like this.
And so I don't get, what's the Sky 360 lib in C++?
Lib. Sky 360 lib is a library that I'm building in C++. Okay. That has the background sweep tracker algorithm that we are calling on Simple Tracker and has the blob detection that we're using on Simple Tracker also. Okay. And mainly all of the algorithms that we'll be using on Sky 360, I'm trying to build there so we can use from just one source, and that will be optimized for our use case, and not a generic thing that we are getting from the internet. So all of these leaves that I'm using there, the background subtractor and the blob detection, were made by me, based on something else, but that's it.
But ultimately, the goal is to run the Docker container on the Raspberry Pi or a Nix package or
Nix, an image.
Nix, okay.
Yeah, a Nix image.
But okay, wow, nice.
So that's what you
right now.
And Wayne did is just a step in before. It's
Okay.
Only that we do not have that set up right now.
Okay.
Idaho is not that far, so that's why. And we do not have all the. Everyone has an Orange Pi 5. But that will come. So at end of February they are set to be shipped.
Yeah, I was the first one to get it because I got it on my own on November, end of November. So, but it's running. It's a great piece of equipment. So
you got the 8 or the 16-bit?
I got the 8 one.
The 8 one. Interesting. I ordered the 16 gigabyte. The gigabytes. And now they say that the 16 gigabytes are out of stock, and they now have to procure 2 times 8 gigabytes to put on, something like this.
Oh, yeah. It might have been the one almost everyone jumped for, the 16 gigabytes one. So yeah.
I mean, it's the same board. It's just that you take 2 or 1 of these 8 gig blocks, something like this.
Okay. Yeah, I don't know. I just put it last week or the week before. I just put a NVMe SSD drive there also, so I could record at least the videos that I'm producing.
Yeah.
Because saving them on the MMC chip is very slow. So I got something else at least to save them, because it was slowing down everything when I tried to save video.
But hey, great stuff. Cool that it's now running on the Pi 5. Oh, I was so worried because we already ordered 20 Pis.
No, it was running only Pi 5 for a while, but I was trying to make something that at least it was displayable, because the most difficult thing for me right now is working with the SDK from KHY, because it's not a very straightforward way of doing things. Because, for instance, I have 2 KHY cameras here, the 183 and the 178, and if I try to use the same method for both of them, it doesn't work. One runs good with live video and the other one doesn't. One runs great with the single frame mode and the other one doesn't, and it's a mess. So I'm trying to make something that works on both of them, so I can switch, because it's not the SDK that they display it's not the best solution for it. So anyway, it's working.
Say Fabio, are you familiar with Rust?
I am familiar a little bit. I just played with it. Never did anything serious on Rust. But I tried making it. I tried helping Ido do get this the KHY SDK in Rust working, but we couldn't. It was a complete mess. Me and Ido, we tried it, and it didn't work out.
So Christian managed to have that, but he's
great.
now into something with the wrong parameters that were set. I don't get. Please don't.
No, that's the problem. It's working in C++. The thing is that we have to configure the camera in the right way, or else it won't work correctly. That's what I'm trying to say.
Yeah.
And both cameras, I have to complete it like in one camera. I have to enable single mode and then do something for it to work, and then do something else. And the 183, I have to enable live video and do something else, or else it won't work. It's like just putting the right parameters for each camera.
Probably yes, yeah. The thing is that at the end we will have our own driver, and I think and I will ask you if it makes sense to you to make contact with Christian. Maybe you are a help to him, because I know that he has some family issues at the moment, and maybe it's just time that he has missing. But I think it would be very helpful if you can have a chat with him and talk about his status and what is still needed.
No, that's fine. I did that also connect directly to the SVU and SDK because I wanted to try the background subtractor and the block detection algorithms with 16-bit images directly from the camera. That's why I did it directly, and it's working. So I already tried with 16-bit images and live video feeds, and so everything's working. So nice.
Wow, cool. And you mean 16-bit with the background subtractor is already working? Did you just say that?
Yes.
Okay.
Okay. It's working, yes.
Okay. Wow. Wow. Wow, that has to settle. Wait a second. Okay, so basically we're big steps closer to the alpha. Definitely.
Yeah, I can get 16-bit images and I can put it through the background subtractor. It works great, no problem. And also to the block detection and the whole pipeline. But at least here, I didn't try them on the simple tracker yet because we have to connect the camera and try simple tracker with a 16-bit feed.
Yeah. Yeah. Wow. So there are, for my point of view, several parts missing for the alpha, which is the driver that Christian is working on, the ROS core part, the decision-making part that Ido is working on. Then we have, let's say, a kinematics thing that is still in work. I think Lionel Yannick. There's an image recognition part that is somehow stalled, and we can pick that up, but it's not necessary for the alpha. And then there's pardon me.
And we have Mike connecting them all. Mike can connect everything with ROS, yes.
Yeah. And then there is Rebecca's work to represent it in the user interface. So that's the things that are still open. And yeah. Anyone else who wants to present something? Otherwise, I'd say we're over the clock. We can make a short day if you want.
I don't have anything to present, but I'd like to just. So David hasn't been able to join today because he's busy with a house move, but he has. Yeah, so he has managed to write a background subtractor using Python, like a state-of-the-art background subtractor using a paper and Python, which seems to be working really well. And we will, when he's ready, he's hopefully going to ask Fabio to convert it into C++. So the cool thing there is we've got someone that has the ability to interpret those papers, those paper things that they publish, and convert that into code that we can then interpret into something, which is, I can't do that. That's a bit difficult for me. So yeah, so he's able to do that. So I just thought that was quite neat. He's busy at the moment, but hopefully next week or the week after he'll be able to demo something.
Yeah. So
that's
is he talking about a particular background subtractor or more in common?
Yeah, it's a new one. That's there's a paper that was published, and I can try and post it in the chat window. Let me just. Yeah, so I'll post it in the chat window. The link to the paper, and this is essentially the one that he managed to implement. and he said he was he was quite impressed with the results. So we'll wait and see. So I just think it's nice to have someone that can do that, really.
Now I can remember. He was talking with me about a paper about small, tiny little objects. I can remember. I was talking with him about the bees. There was also someone in Europe investigating into bee detection in a grass field. Okay, cool, good stuff. And the idea basically is, please correct me, Mike, if I'm wrong, to have a deep knowledge of a certain background subtractor, so to know what each parameter really does and influences the outcome, and then to have a kind of a neural network finding the best parameters for each daylight situation, right?
Yeah. So yeah, no. So I don't understand the neural networky side of that. So I'm very woolly when it comes to everything running through a neural network and it deciding what the best parameters are and all these sorts of things. So I don't quite, so that bit I haven't wrapped my head around that. But I think what we can do is there's an element that we can process a bunch of videos and come up with a certain preset list of parameters that work better or best in a certain situation. But plugging all that stuff into a neural network and having it decide, I don't quite know how that works.
Naja, basically you feed all your parameters, so you have your realm of all your parameters. You can say, I don't know what that background subtractor has, and then you compare it with the results, and somehow he has to weight the results to give them some value, what the outcome is. And then, yeah, you get a neural network that always finds the best parameters to get the best outcome.
Yeah,
that was basically
and we'll have to train it for it to get the best parameters. So
because the realm of parameters is so big.
Yeah, and also we have the problem with the camera itself and the exposure and everything there, because we have several parameters to play with to get the best relationship between exposure time and frames per second and everything like this. Because right now, for instance, it's very dark outside, and I have to increase the exposure a lot. And so if I increase the exposure a lot, I will reduce the frames per second. And if I reduce the frame per second, then I can have to increase maybe the gain. So have a lot of parameters to play to get a good image, mainly with when it's dark, it's getting darker. Because when it's everything, we have light, that's very easy. We can just play with the lowest exposure rate, that's fine. But when it's getting darker, we start to have problems. And between the frames per second and the resolution and the gain, so we have to play with a lot of different parameters. We can play with beam modes, we can play with gain, we can play with exposure times, we can play with gamma and blah blah blah, contrast, brightness, and that we have to figure out, or else we'll be unable to function at night nicely.
So if you talk with Christian, it is already all figured out, because it is also everything is nothing new. So what he's doing is implementing this all in our own driver, firmware he calls it. So these algorithms are there in place. And he knows all the parameter space. So if you want to have a deep insight in this, then you have to invest some time with Christian. But take some time for that.
Yeah, I know, because I'm trying to sometimes I'm trying to work at night here. I'm trying to figure out something for me to work in, but I cannot figure out the correct parameters, because I have to increase exposure, increase blah 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 blah, and so in the end I just work with videos.
There are strategies and algorithms that deal with that, and they run in the firmware. They already do it, but it's a big difference if you have a driver for, let's say, an astronomic use, or a driver for everyday web camera use, for example. And even
that's
the
true.
astronomic driver that is there, that's the QHY CCD SDK driver. That's the one that QHY publishes themselves. They call it the astronomical driver. That one has so many limits and boundaries to all these profile curves are all theirs. As a normal user, you take the driver and you have to live with it. In our case, we can tweak everything. That's a nice thing. But in this case, you also have to know every parameter and what it does and what's it's worth for, and also to implement your own algorithms. But Christian has that all. It just has to to work. I mean, he made it up to that he can code it in Rust. He made FX load implemented so that it is uploaded. The firmware is uploaded to the camera in runtime. He can even kick it that it is uploaded, so you can, from frame to frame, we can change parameters on the camera in the firmware, and we can even within a couple of seconds or milliseconds, we can update the firmware on the camera. So we have all possibilities open because of that.
Okay.
And then there's the second part with the dealing. This is the background subtractor, because when you have a night situation, a daylight situation, you can fuzz around with gain and exposure time as much as you want. You have your boundaries because there's much more light in day than in night, and of course you get some sweet spots somewhere with gain and exposure, where you say, okay, now I have to live with that setup for the day and I have to live with that setup for the night. But then you have different weather situations where it can be during the day, it can be pitch black when you have dark clouds coming over and so forth. And then this other level of the background subtractor, what David is working on to find for each weather situation the right setup for the background subtractor, because the parameter space is so big, and every little knob you twist gives you another outcome. So that's why I think the idea for going with a neural network to find the sweet spots in this parameter space, I think is a great one if you manage to succeed in that. But it's certainly no one did up to now, and I'm not aware of any project like this. Yo. Anyone else?
Yeah. So I wanted to thank everyone who's been helping me this week with my issues. So last status for me was that I determined that with the last once I have the QoS version of the code, I stopped receiving frames from one of the nodes stopped receiving frames from the camera node. So the camera nodes outputs 10 frames, and the annotated frame provider, while the processing node receives only 1 or 2. So there was a discrepancy there. So that's what I've been able to determine. And I was wondering if anybody has any idea as to where to go from there. If not, I'll find somewhere to go from there, but maybe I can...
Yeah, so the only thing I can think of, like personally, what I would probably do is to try and change the QoS profiles to the default QoS profiles. So currently we use the sensor data QoS profile. So there is a QoS profile which is like I can't remember the exact name, but it's the default one. Which
system default and sensor data.
Yeah, so the system default one essentially picks up the default settings from the DDS pipeline, I think. So if you maybe change, it should just be like in VS Code, you should just be able to do like a global search and replace, where you like pick one method and replace it with another method and pick the default one, and just so what I would personally do is I would do that and just see if that changes things, because Yeah. So
Okay, I'll try that. But
yeah. So I was just thinking that maybe. Sorry, mate. I was going to say I was just thinking that maybe it's there's like a time to live, or I think it's called lifespan, and the only thing I can think of is that that's expiring, but that is set, I think, on the sensor data QoS profile. That's set to half a second. So yeah, so that's the only thing I can think of off the top of my head is to change that. Just see if that reset those QoS profiles to system default and see if that makes a difference.
okay. And just a general question with regard to QoS. Let's say I implement a new ROS system from scratch, and I start emitting some message as a publisher, and I know nothing about QoS, so I'm not marking the packets.
It'll pick the system default.
Are they marked regardless, or
is
that like an empty field that's missing?
Yeah, so essentially, if you don't specify a QoS profile, it picks the system default. So there's a which is specifically geared towards backwards compatibility with ROS1.
Okay.
So it doesn't. And also bear in mind, I'm very new to this QoS stuff, right? So I only started looking into it recently. But my understanding is currently the sensor data, as an example, the reliability portion of the profile. So for sensor data, that is set to best effort, whereas for default, it is set to reliable because in ROS1, it used to be TCP versus UDP, which is a reliable protocol, and this sort of stuff. So the profile, the default profile, is different to the one that we currently have selected. I don't know. Sorry, there was a bit of a.
No, it's something to.
Does that make sense?
Yeah. Okay. I'm just gonna try that. That's easy enough to try. Okay, it's starting to make sense in my mind, because it's not always easy to figure out one's meaning via text chat. So now I got your point. Okay.
Yeah, it's quite abstract, this stuff as well, and it's quite yeah. I'm sorry. It's gonna take a while to It's gonna take me a while anyway to get my head around this stuff. So I would appreciate any information that you have, and if you think my understanding is wrong, say it. And if I think your understanding is wrong, then I'll do the same. And we'll help each other kind of understand QoS better. I think, because the only thing I have at the moment is really the ROS documentation, and to try and interpret that and try and get an understanding from that.
Okay.
So okay.
Okay, so I'll double check and try that system default on all receiving nodes then.
Yeah, so you will have to do it on both publishing and receiving nodes, because if you do it just on receiving nodes, because the publisher is set to best effort, the receiving node, if that is set to reliable, won't bind to the publisher node because it's of lesser reliability.
Mm-hmm.
Does that make sense?
Yep.
So when you subscribe, the node that's subscribing needs to be of lesser or equal than the one doing the publishing. If the one doing the publishing is lesser than the one doing the subscription, it won't subscribe.
I don't subscribe.
No, it just refuses to, because it can't guarantee the lowest common denominator. So yeah. So you would have to make the change for both the publisher and the subscription node. Okay,
we'll do that.
Best of luck, man.
Mike, is there a configuration that is true for all nodes across a QoS configuration profile?
Yeah, so currently I've set the QoS profile to be the sensor messages profile, because I set it to that locally and I didn't have a problem with that. But obviously other people are having a problem with that now. So I was gonna Yeah, so I'm just trying to think how to articulate this. So basically, what I was thinking of doing is I've got a shared Python script class that has a method that you can use to query, like get the publisher QoS profile and the subscriber QoS profile. I don't currently use that. The function that gets the QoS profile is like a system level script. But what I was going to do is I was going to revert it back to using my shared script so that we then only have to change it in one place versus everywhere. I don't know if that's making sense. Sorry, I'm really bad at explaining
No, it's
stuff.
I saw that I saw the pieces of code, so it's easy to
make
change
sense.
for me. That's the way I would change. I'm just going to use that piece of code to change it system wide.
Yeah. So okay, man. So yeah, I'm just trying to think now. So yeah, if you experiment a little bit and just feed back to me what you find, and then we can always make a change and do a PR and just update the repo, you know, with something better. The implementation of QoS that's currently there is just a starting point. I'm not, you know, don't for 1 minute think that's how it's going to be defined. It's purely just a starting point because I wanted to get QoS into the product versus not having it in the product. And so it's just a starting point. If it's not correct, then we need to make changes to it.
Okay.
Sorry, yeah, I'm not the best at
easy
explaining
enough.
stuff, man.
It's fine. I get it.
Okay, cool.
I see what you do. Thank you.
Okay.
Thank you for that.
No worries.
And yeah.
Okay, cool. Anything else? Someone I did not hear? Okay. Yeah, so then have some last words for today. Ido, if you hear us, a big shout out to you and be healthy soon. And with these words, we say goodbye to Ido and all others, and I stop recording.